In this video, we will discuss sort the given list of elements using Raptor. I am Dr. P.V. Sena from CBIT. So the idea behind it is, read the number of elements, assume that my n value is 6. So what are that elements? So the elements are 666, 777, 88, 99, 98 and 100. So the number of elements is 6. So what are that elements means? These are the elements 666, 777, 88, 99, 98, 100. So these are the list of elements. So at the end of this program, I need to get ascending order list. Ascending order list. Arohana kramam, small to big elements. So 88, 98, 99, 100, 6, 666, 777. So I need this required output. So for that purpose, once we are reading the number of elements 6, so we are storing in these values in array, one-dimensional array, A of I. So always I comma j will refer the indexes here. In Raptor, the index starts with 1, 1, 2, 3, 4, 5, 6. So these are the indexes. The values at that memory locations are 666, 777, 88, 99, 98, 100. So in this way, the given list of elements are stored in this array. The number of elements is 6. What are that elements? These elements are stored in this memory locations. At the end of this one, I need to get ascending order list. Arohana kramam, small to big. So for that purpose, we have different strategies. So we need to apply the simplest strategy, that is said to be a bubble sort algorithms. So the bubble means a lightweight element. Here, the highest weight element goes to the its correct position, last positions in the first iterations. After first iteration, the biggest element goes to the last position. So that element we need to ignore for the next iteration. Second iteration, we are ignoring that elements. It is a simplest sorting algorithm that rapidly steps through the list. So here compare the adjacent elements. So we are comparing the adjacent elements j comma j of 1, array of j comma array of j plus 1, and swaps them if they are in the wrong order. If they are in wrong order, then we are swapping it. Swap means interchange these two values. The process is repeated until the list is sorted. So this is the basic bubble sort strategy or algorithm. We are in outer for loop. We are starting at 1 actually, I less than n I plus plus. For j is again 1, j less than n minus I, j plus plus. If a of j is greater than a of j plus 1, if they are in wrong order, then we are swapping these two by using this temporary variable into temp is equal to a of j. A of j is equal to j plus 1. A of j plus 1 is equal to temp. So here this code in C, C++, Java, it is working. Y means index starts with 0. If you take the Raptor, then you need to start the index with 1. Outer loop. So this is inner loop. So outer loop is indices with I, inner loop indices with j. So we are comparing the adjacency elements a of j and a of j plus 1. So if a of j is greater than a of j plus 1, if the elements in wrong order, then we need to swap these two elements. So this is my algorithm or strategy here we are using. So by using bubble sort, start from the first element of the list, compare the current element with the next element. So if the current element is greater than the next element, swap them. Interchange these two elements by using the swap. Move to the next element and repeat the comparison and swapping process. After each full pass through the list, the target unsorted element will be bubble up. So whatever the highest element, highest weight elements is goes to last positions after each iterations. I repeat this process for all the elements, but with each subsequent process, reduce the range of element to compare. Suppose after first iteration, one element goes to the last position, the biggest element. From next second iteration, you need to ignore that element. So after second iteration, two elements goes to the last positions. Two biggest element goes to the last positions. You ignore that two elements from the next. Continue until no swaps is needed, meaning the list is sorted. So this is the internal working procedure of bubble sort. Here I am taking the indexes I comma j values a of I. So 666, 777, 88, 99, 98, 100. So these are stored in the memory location like that. So next, so I am taking this pass one. That is, I am comparing the first two elements, 666 and 777. So these are ordered ascending order. 666 is greater than 777. This condition is false. No need of swap elements. So next we need to compare the next two adjacent elements. 777, 88. So 777 is greater than 88. In that case, the condition is true. It is unordered. It is not in ascending order. Then we need to swap these two elements. So 88 comes to here, 777 comes to here. So next 777 and 99. You need to compare these two. So 777 and 99. So in this 777 is greater than 99. This condition is true. Then we need to swap these two elements. So 99 comes to here, 777 goes to here. Again, 777 and 98, you need to compare. 777 is greater than 98. This condition is true. Again, we need to swap these two elements. So 98 comes to this position and 777 goes to here. So 777 and 100. Again, this 777 is greater than 100. Again, this swap is required. So right. So after this first iteration, so whatever the highest element, the biggest element goes to the last position. So next iteration onwards, we need to consider only this n minus 1 elements. N minus 1 elements. No need to consider this last element. Right? So after first iteration, the biggest element goes to this last position. If there are in this way, only n minus 1 elements will be there. After second iteration, we need to consider n minus 2 elements. After third iteration, we need to consider only n minus 3 elements. So this process is repeated until all the elements will be sorted. So the main logic here it is, so we are reading outer loop and inner loop. So in this inner loop, I'm comparing a of j with a of j plus 1 adjacency elements. If a of j is greater than a of j plus 1, if it is unordered, right? So the biggest elements, if it is unordered, then we need to go for the swap. Swap is temp is equal to a of j is equal to a of j plus 1, a of j plus 1 is equal to temp. So by using this simple swap logic, I'm swapping the two adjacent elements which are unordered. So this is inner for loop, this is outer for loop is incremented. So the full flowchart representation here it is. So I am reading the number of elements. What are that elements? So once I read this element, so I am using this inner for loop to compare these adjacency elements. In this inner for loop, I am comparing this adjacency element a of j and a of j plus 1. If there is unordered, just I am swapping these two elements. So next inner for loop is incremented by j plus 1, outer for loop is incremented by I plus 1. So this process will be repeated until all the elements becomes to sorted. Right? So this is output. The elements are here. 666, 777, 88. The given elements is, once we are applying this strategy, it is bubble sort logic, the elements becomes to 88, 98, 99, 100, 666, 777. So this process is repeated until all the elements becomes to ordered. Right? In this way, you can try to these problems. Think the best case, worst case, and average case time complexities. Suppose here the best case, assume that the elements is already given order 88, 98, 99, 100, 666, 777. If the n value is 6, so we need to compare. Yes, 88, 98, swap is not required. 98, 99, swap is not required. 99, 100, swap is not required. So 100, 666, swap is not required. 666, 777, they are in order, swap is not required. If there are n elements, we did n minus 1 comparisons. If there is no swap is required, you simply use the break, come out of this one. So the time complexity is the number of comparisons is order of n minus 1. The time complexity becomes to order of n. So next, this is said to be the best case analysis in bubble sort. Suppose if it is in worst case analysis, in that case, we need to take n elements. The number of comparisons is n minus 1. So next, n minus 1 elements, n minus 2 comparisons. N minus 2 elements, n minus 2 elements will be there, n minus 3 comparisons we are performing. So n elements, n minus 1 comparisons, n minus 1 elements, n minus 2 comparisons, n minus 2 elements, n minus 3 comparisons. At the end of this one, 2 elements, 1 comparisons. So the sum of comparison is sum of n minus 1. Total comparisons become to sum of n minus 1. So what is the formula of the first sum natural numbers? So the sum of first n natural n into n plus 1 by 2. So we require sum of first n minus 1, n into n minus n into n plus 1 by 2. So order becomes to n into n, order of n square. That becomes to worst case analysis, order of n square. The sum of first n minus 1 natural numbers, that is n into n minus 1 by 2. Here it is, that is becomes to n into n minus 1 by 2. Then the time complexity becomes to order of n square in worst case analysis. So average case is also equal to worst case here. Order of n square means 1024 into 1024. 1024 we can write 2 power 10. So again 2 power 10. So 2 power 20. N log n. 1024 into log n value is 10. 1024 into 10. So we need to compare these. Try to find out some alternate solutions. Right? Some alternate solutions. Here it is. We have discussed bubble sort only. There are other sorting strategies like selection sort, insertion sort, quick sort, merge sort, heap sort, radix sort, bucket sort. You can learn slowly.